Hey guys, welcome back to the channel. Glad to have you all here. Hope you're having a wonderful weekend. I'm going to try to keep this video short and simple, to the point, just a little weekly update of what we've been doing. Mainly going to touch on the fuel system and the electrical system, because that's the biggest things I've been working on. A couple of other things I'm going to have to work out. I did get an overflow tank mounted, but as you can see, it's hitting my airbox. My airbox is actually cocked off to the side right here to get it on, to get it out here and run it. But I'm either going to have to shorten this or relocate the overflow. I hadn't figured it out yet. So we're going to figure that out this week and see what we can do right there. Moving into the electrical system, I've chosen the batteries. I'm going to use a dual battery setup. And one of the important things in an airplane like this is weight, right? We don't want to make it too heavy, especially with this right here. This conversion that we have on the airplane is heavier than the Rotax that's recommended for it. Clark mainly chose to do that while he was building it, because with the Rotax, he had to shove a whole bunch of lead up here in the front anyways, about 100 pounds worth, right? So why shove 100 pounds of dead weight in it when you can just put a heavier, cheaper, more easily sourceable and replaceable engine on the front out of a Geo Metro? So that was the reason they did that. But we're forward heavy on our CG, right? So we have to be real careful. What kind of word is that? Careful about how much weight we stuff up here. So I chose to go with lithium iron phosphate batteries instead of lead acid, just because the technology is so much better. They're more affordable now than they've ever been. The performance just blows lead acid out of the water, and I've had good experience with them. I've used them in my boats with zero issues, and honestly, they took more punishment than any lead acid I've ever had. No matter whether I spent $500 on the lead acid battery or got a $100 one from Walmart, they all kind of seem to behave the same, and I've got pretty good confidence in these I've bought, and the technology that's built into the starter battery is really, really sweet. I'll show you guys that. But my secondary battery is going to be this Ionic deep cycle. It's 20 amp hours, 12 volts, weighs 6 pounds. I mean, nothing. It doesn't weigh shit, and the starting battery is even lighter. But this right here is going to run the avionics and the radios, and that's it. I want to do everything I can to try to eliminate electrical interference in the radios. I want it to sound as good as possible. I want the avionics to perform as true as possible. So they're going to be isolated to this battery. I also had this planned out for a BRS parachute until I started pricing them. and we're not going to have a parachute, so we're just going to have to try not to crash. So this one's just going to be dedicated to the avionics and the radio. Great battery. Love them. They last. They really last. I can't pull the starter battery out because it's actually in and wired up. But it's it's an Ionic as well. They're based out of North Carolina. It's 9 amp hours, I believe. Let me reference my notes here. Yeah, 9 amp hours, but all it's doing is running the engine and the lights and stuff, right? So you don't need a big deep cycle reserve on that. This thing charges up really, really fast. So it's going to be good for the starter. It weighs 4 pounds. It's even lighter than that thing, and it's twice the size. I think it's basically just because of the difference in the type of cells, the starting cells versus the deep cycle reserve cells. But one cool thing that I want to show you about this is the apps that come with them. That's the wrong phone. I got the app on this one. This is the app for my starting battery. They both got a different one. but I want to show you all that. See, it's got the button there in the middle. That's our on-off switch. So right now I've got every switch in the airplane turned on. The lights, the dash lights, the fuel pump, the ignition switch. And as you can see, this battery is not getting any type of drain. If you want to check detailed stats, you can see it right there. We're chilling at 13.4 amps, 99%, gives you the temperature, all that good stuff. So instead of having a heavy contactor in the front, just add more weight to the forward CG, these starting batteries from Ionic have on-off switches built into the BMS. And so all you have to do to turn the battery on is press that right there. How cool is that? I don't think you can see it now. You can't see the little landing light, but you heard the fuel pumps turn on. And it shows our connection. It shows at this amp draw, we've got about an hour and 19 minutes of battery life left, right? So all you do to turn it off again, just hit that. You're fully disconnected, no drain, or anything like that. So that saves having to put an additional switch on the dash panel. You just do it right from your phone. Well, what if your phone dies? I know what you're all thinking, right? There's a button on top of the battery. So you just open this door, turn the battery on. The BMS or battery management system is set up to it will not turn off until the battery hits 25%, right? So, and that's, if it's charging, it's never going to hit 25%. And if you leave it off, if you accidentally leave a switch on, so you go to a fly-in somewhere, you park, you forget to turn something off, it'll get down to 25% and it shuts everything off and leaves that 25% reserve in it. You go in the app, you hit emergency start, it gives you access to that 25% that's left to start your engine and get it charging and all that stuff back again. So I really, really think I'm going to like that. I'll give you guys a quick rundown of the schematic. It's not very detailed, right? This isn't in the final, but this is kind of how I'm going to have to do everything since we're working with a single alternator setup. That's going to feed battery 1, which is our starting battery that I just told you about, the engines, gauges, and lights. We're going to have a crossover wire going over to battery 2 that we first mentioned for the avionics and the radios, right? And we're going to have a diode in the middle. That way, none of this stuff will be connected to battery 1. So you don't get ground loops, you don't get backfed electricity. Diodes will only, think of them as a one-way gate for electricity. They just let electricity flow into battery 2, but will not let battery 2 backfeed battery 1. Okay, so you're thinking, these newfangled batteries you got, what happens in an in-flight emergency? Number 1 battery dies. Well, that's where we're going to put in our contactor right here. It's going to be an emergency battery crossover with a switch to the dash. If for some reason shit goes wrong with this one, I can hit a switch. Battery 2 now connects to battery 1. We can refire the engine, gauges, lights, all that stuff will work. And then we're just going to have another contactor for the battery 2 switch for the bus to run the avionics and the radios. So yeah, I think that's going to be a pretty good deal for the electrical system. It would have been ideal if we had dual alternators, but it's not an avionics engine, so we got to deal with what we got. There's really there's nowhere to squeeze another one, even if I wanted dual alternators. But this one puts out. I was checking on my app for the batteries, 17, 18 amps at idle. It charged. This battery was at 56% when I installed it, and it charged it to 100% in 5 minutes, maybe. I think you saw on the app there it was 99% now. So no, it's been doing great. But enough about the electronics. Let's move on to the fuel system, because that's the last few videos that's kind of what we've been focusing on, right? Well, everybody remembers this from our coffee and conversation videos, just ideas in my brain getting to paper. And, well, now ideas come to life. Ta-da! So here's our header tank that we talked about. I did wind up shortening it an inch. So it's 5x5 by 10, I believe that was. It's going to give us, it gives us right at about a gallon. No leaks. Surprisingly, I really struggled with this one. The practice one I did turned out better. It turned out better looking. One thing I didn't account for when I was practicing is with this final product, right, we had to weld the bungs in the bottom and the top. We had to drill holes and weld it in. Well, you can't do that when it's all together because you can't get the shavings out. So I took each individual plate, marked them out, drilled it, welded the bungs in. Well, aluminum gets so hot while you're doing that, the top and bottom plates started warping. And I did everything I could to keep them straight, but it just resulted in some bigger than normal gaps that I had to fill that I was not used to. I'm a very, very, very inexperienced TIG welder. I bought that machine 3 weeks ago and taught myself how to TIG weld. So I'm very excited to have this thing together and no leaks. Before I put it in the airplane, I took a vacuum gauge, I plugged off all the holes, ran a vacuum gauge into it, and I put 5 inches of vacuum on it for 10 minutes, and it held. To my surprise, I figured there was something I was going to have to do to address it, but it held vacuum. I welded up some brackets, put it in, bolted it in, and it seems to be doing good. One thing I'm going to do, I'm going to take these brackets loose and just put some rubber isolation grommets on it just to help dampen the vibration, because I don't want anything. I mean, this is 5052 structural aluminum, and it's got, I forget the filler wire I used, but it was very high tensile strength structural filler wire. So it should be strong. Nothing should happen, but an ounce of prevention's worth a pound of cure, right? So I don't know. I don't remember exactly what I talked about in the video. I probably should have watched it before I filmed this one, but hey, we'll just shoot from the hip, right? So our specifications coming out of the tank, running down and into our header tank is all now 6AN PTFE lines, so we don't have to worry about ethanol contamination, which we're only going to run ethanol-free fuel in this thing anyways. But if we ever get in a pickle or some water or something accidentally gets in there, we don't have to worry about that. But we got 6AN coming into the top, feeding this thing. Our main fuel filter, the line coming out of it's an 8AN to try to create some suction, right? When this thing's pumping, we've got 6AN down here, we got 8AN up here. That's going to create a pull to help pull fuel into this because it's not vented. And the way we get around that, well, if it's not vented, how does it fill up? Well, it's because this is a return type style system. This line right here, this 6AN line coming out of the top, is our return. So we're constantly sucking fuel in and then blowing it back into the main tank. So it took a while to get it primed out, but it's now fine, right? It's gravity fed into it, and then we've got these pumps sucking fuel, sucking more into it, blowing it back into the top tank, and so no issues there. But yeah, dual Walboro fuel pumps that we talked about before. This is not finished, right? This is just for running purposes, keeping it off this heater pipe or the radiator pipe. So yeah, dual 6ANs to a Y. This is our 40 micron filter, 100 micron filter. I might have that backwards. Anyways, this is less restrictive, more restrictive. Okay. I've got a fuel pressure gauge in it now, so we can monitor the high pressure fuel pressure. and keep an eye on that. And then, like I said, another 6 AN PTFE right back into the tank. So yeah, I'm happy with it. We're going to run this one as an emergency pump. So this will be ran to a switch in the cabin, sort of like a boost pump setup. We'll have both of them. This one's engine driven. So yeah, if anything goes wrong with that one, or maneuvers, landing, taking off, things like that, we'll run both of them. Make sure we just get plenty of fuel. I mean, both of these are rated to flow 225 liters per hour. So we got plenty of gas going up to the throttle body. But yeah, that's what we've been working on. Super excited about it. So what do you say we let her run? All right, a demonstration of how the app works. You can see I've got, well, you can't see it, but I have every switch in the airplane on, including the ignition. The battery is just in standby. It's not discharging at all. It's ready to go. So let's go fire her up. Like I told you before, all we have to do to start it is just hit the little green button on the app. That turns everything on, and you just hit the switch.
All right, I know it's loud with the airplane running, but I just wanted to show you the app, what the battery's doing while it's running. So they quit turning off. We're holding at 14.3 volts. It's full, so the battery regulator inside the battery is just keeping us at about 2 amps. 100%, 82 degrees on the battery, and everything's good to go.
Yeah, so overall, I'm extremely happy with the progress. I haven't seen any leaks, and so far it's had at least 30 to 40 minutes of runtime on it. So we'll keep an eye on everything we put in, these hardline connections, all that stuff, to make sure nothing goes wrong. But she's doing great, and it's thankfully time to move on to some less labor-intensive projects. We'll do some fun stuff, some wiring, some avionics, and get this bird ready to fly. But thanks again, everybody, for joining. Tell all your friends if they want to keep up with the story. I'm sure we'll get into some more interesting things to overcome and figure out. And I just love sharing the journey with everybody. Along with documenting it for the FAA. But I appreciate every one of you being here. We've grown a lot since we first started. So thank you all very much. I love you, and we'll catch you on the next one. See ya.